want to talk about how we got, if not to Nirvana, which is the end state people have been talking about, then, Nirvana's right there. I can almost grab it. It's so close. Because if you have, the big classic brownfield cratered mess that, who here has a big cratered monolithic mess that is agonizing to work on? Who here has a beautiful, well-factored, lots of services thing that is, if not beautiful, at least not quite as horrible to work on? Okay, so it's about 50-50. So if you're in this world, which we were 2 years ago, where we had a huge Rails code base that, I don't know, let's see, people would quit rather than work on. You were unable to hire because it had a reputation. We wanted to just change the UI across all the pages, and that was, how long was that project, Sean? A year effort?
Yeah, about a year.
Which failed totally. I mean, it literally was like the classic worst case monolith end state that you can't do anything with. And so, we sat around and said, well, it'd be really nice if we could split this up. You've heard the microservices talk, and we said, okay, we're going to do Node for this. And so rather than talking about what all this was and the idea behind it, you've heard that, let's talk about how we got there. Because we tried the big, oh, I got to stand, I can't do that. I'll just wave my arms around a lot to make up for it. Okay, so if you oh, I'm going to get in trouble. I forgot to record. Okay, so how do you get from that giant monolithic mess to something reasonable incrementally? Because we'd already tried to do the rewrite. It failed miserably. We wasted a year of engineering effort. That's not cool when you're a 4-year-old company at the time. That's a quarter of your entire company history sort of down the drains engineering-wise. So let's do it incrementally. So we, okay, if we were logically, we want to have a single page is an application unto itself. What's the smallest unit you can do to test that out and verify it? You said, okay, we'll take one single page that looks different than everything else, because that makes it easier. We'll take, our basic, hey, welcome to Groupon. Please sign up and give us your email address so we can send you emails with awesome deals. And they are awesome. If you haven't filled this form out, go fill it out. Let's do that. So let's take a single application. And I stood up, we have the nasty Rails thing. But what it actually looked like, and this is important, is we had the nasty Rails thing, and then we had copied and pasted the nasty Rails thing, and then put a bunch of APIs on it instead of web pages. And so we had the nasty Rails thing and the nasty Rails API thing, which were the same code base, but evolving differently now. But this was good, actually. Really, really good, it turns out. And we'd done that so that we could stand our mobile stuff up and have all the same business logic. And so we said, if we want to stand up that single subscription flow page, let us have it talk to those same APIs, because the mobile app can do everything. That Rails app can do everything. So let's try it out. And so the gentleman in the corner here, Sean, wrote our first Node application 2 years ago, which was the subscription flow. Not super exciting, and it was tiny. It was, 238 lines, including the makefile, which I didn't realize it had a makefile, so I'm trying to figure out why CLOC thought there was a makefile there. Interestingly, we used CoffeeScript. I want to talk about that briefly, because we had a ton of Ruby-oriented Rails developers who'd done some JavaScript, but the JavaScript they'd done was basically jQuery or Prototype if they'd been doing Rails for a while. But we don't talk about that. So one of the problems coming to JavaScript is there's some sharp edges in JavaScript. It was written in, 2 weeks? It's finally getting some nice soft edges. And so CoffeeScript, despite being, sort of like the redheaded stepchild of the compiled to JavaScript languages, has a couple of really, really nice attributes for us. One, most of the sharp edges of JavaScript are kind of smoothed over so that you get the behavior you expect. And two, there's no big runtime to load, like with TypeScript or ClojureScript or anything else that compiles to it. And so you pretty much, you write CoffeeScript, you get very equivalent JavaScript, there's not a lot of overhead, and it's nice and easy to work with there. I'm getting lots of pictures taken. Anyway, so we wrote this up, we stood it up, and it fell over horribly. Because we were a bunch of Ruby people, we'd done browser-side JavaScript, we didn't have an idea. We had problems with, SSL termination, we had problems with, wow, no matter how much capacity we add to this, we only seem to get, about this much throughput to the back end, because we hadn't configured the number of HTTP connections it was allowed to establish to a server. Apparently that is a really big deal in Node. Luckily, this was solved before I joined. But we worked through those operational issues, we worked through the different language, and in the end, that one page worked. Yay, we have a micro web app, except it's one thing, and it's totally different than everything else. And so if that was the minimal experiment we did to validate it, it succeeded. We stood Node up, it worked, it carried, every first-time visitor to our site, which at the time was slightly more than half of our business, and now is slightly less than half of our business compared to mobile. But it was good. But you had to go on to the next step, and it was kind of painful. But for the next step, again, we didn't really want to go small, so let's pick something big. At Groupon, we show you deals. You want to buy deals, you want to buy vouchers for great things. So let's show you the browsing all the different deals that are available. This is kind of core, it needs to work. And so logically, we just add one more box. It's another page, it's another application. But the important thing we got here now is that we have this subscription flow. When we're doing this additional page, we want to be able to do an exact apples-to-apples comparison from the monolithic Rails thing to the new fancy Node micro web app. I don't even know what we were calling them then. ITR app is what we call it. And so we're going to basically be able to A/B test between them and gradually ramp traffic over. Because this is over half of our business going through this, we can't afford to screw it up. And so we said, okay, let's make a good routing layer. And this is something that if you're going to do this, everyone winds up talking about the routing layer. We heard about Composure earlier, which was Composure really like, it was more a compositing than a routing. But if everything routes to it, then it also winds up doing the routing. In our case, we actually wanted traffic to come in off the web and then either be shunted over to the Rails app or shunted over to the correct ITR application. And so we had a very mature sort of multivariate testing application, called Finch and Birdcage, Finch being the client, Birdcage being the server, which does all the analysis and records experiments. And so we said, okay, let's take that and let's actually make our routing layer 100% experiment-based. Because we very gradually want to shift traffic, and we want to measure that it works. If it doesn't work, we want to shift it back. And you want to be able to just, roll that over generally, page by page, URL by URL. And so that's what we did. We actually love to open source this, but we can't because it's tied to the rest of our infrastructure. So we'll figure out how to do that. And so setting up a new route to shim traffic over to the little application is set up as an experiment. You have, buckets, get 1,000 buckets per experiment, so you can do like 0.1% traffic, 0.2% traffic. You can put, your rules for routing. If you want to see a whole bunch of examples of them, you can do an exact match. You can template things in. You can do regular expressions, but you shouldn't because they're expensive. You can put very guards on it. So the experiment only runs for users who are in the office or who are named Eric Lefkowski, who's our CEO, so he sees something special. You can run different variants. You can basically decide what you want to do and then run traffic there. And this is really important because if you look at this graph, which basically shows the purplish pink is traffic on ITIR and the orange is traffic on the monolithic Rails application. You'll see that it's very, experiment, try and figure out how to get there. There's a huge ramp up in the very beginning, and it worked nicely. But then getting the rest of it was tweak, tune, until you get at least parity or lift off of the new application so that we're never actually losing money during the transition, except for opportunity cost of not having done it. And we got there, and it worked. But some of the things that really had trouble here, this application was rewritten a number of times. It was written by a previous, Rails team. It wasn't the core ITIR folks like Sean and the team that was doing it. And so there was a huge sort of learning experience through this with how to do this with different teams. Because one of the big problems we were trying to solve by doing this was how do you have, a dozen different teams all working on this stuff? It was more of an organizational rather than technical because we kept stepping on each other's toes. It was a mess. But we got through that, and I'm going to move quickly because I got too much I want to talk about. So we say, okay, great, we got the browse page, let's do the deal page. Let's start breaking everything out. But if you're going to do even one of them, you actually, once you're solving for 2, you're solving for n. And one of the biggest problems that came up here was how do you actually get them to look alike. Because if you're standing up a whole bunch of pages, they have the same header. This is the same thing that Composure was trying to solve. And we talked about doing different things. We talked about edge side include. We talked about, compositing, having a composition server, kind of like Composure. We talked about client-side rendering, and they have benefits and drawbacks, and most of the options suck. Pick your evil. It's not, pick the best thing. And so, we thought long and hard about this, like, how do you put this together? Do you do sort of, like the nested component, like desktop? Who here's ever written a desktop application? Yes! I thought I would be the only one in the room, except for maybe Fred, because no one writes desktop applications anymore. Do you do sort of the, very bare ESI model? What we wound up at, actually, was we wanted to have a layout server, because each page should have the full control over what it does. If you want to stand up something that is fundamentally shaped differently, like the first page we did, the subscription flow that literally is a form, doesn't look anything like the rest of the site, you need to be able to, but most of the pages have shared layouts. And in the end, you need to get that level of control. So we created a shared layout servers where, each iTier application just goes and fetches a template. And we have a number of different templates, and so it becomes like a read behind instead of a composite in front, and it gives control back to the application layer. The templates are just, mustache templates, their version that uses, semver. We're using Node, semver is popular. So you say, hey, give me version, 3.8, or just give me version 3, or give me exactly 3.8.2. This one's dated because 3.8 was a long time ago now. Sorry, old slide. Yeah, you can see it was from March. And so it just comes through and it looks like this. And so the application just basically is bound to what are the fields it's expecting in the template, and then that's the only dependency there. And so when we finish rolling out iTier, we could do a global switch. This is the look and feel when we started, and within a month or so after we finished rolling it out, every page we switched over to a new way of looking. But again, this was done by the same A/B testing experiment, so we could verify that that all worked. I could talk about other ways of doing layouts, but this is the one that we did, and it actually has been very successful. We also talked about like bundling them into, so you have to deploy everything, and that's a disaster because you want to be able to deploy separately. Lots of things that are available to do there. And it worked nicely. And so we're now in the world where we have 30 some odd small applications. I didn't talk about that well. We then say, okay, let's turn on the fuel. Take, how many initial iTier teams were there? 12? Yeah, exactly a dozen. Let's go build these things and push them out there. And it was hard. And a lot of the learnings there stopped being technical and started being, how do you switch your development methodology from everyone committing and merging into a big code base to everyone having their little thing, where you have sort of dependencies between them in terms of linking across or doing that, coordinating that across teams rather than just saying, oh, that branch is merged, this is deployed. And round about the time that we figured this out, most of the pain became organizational rather than technical, which is great because, then you can get the technical stuff out of the way. But we pushed through that, and we got to a bigger problem, which was we did this for North America, but Groupon largely grew through acquisition in the early years. And so North America represented, I don't know, half of our business or so at the time, and the other half ran on a completely different stack. Here's the North American one. The EMEA stack, the one that runs for Ireland, was boxes and arrows, almost the same thing, except that it was a Java Spring application. It was used stored procedures for most of the actual manipulation of logic. It was architected completely differently, and we really wanted to be able to get the same feature development, front-end development on it. So here's the world we're in. How do we do the same thing if we actually want to, move all of these pages onto the new platform? Now, luckily, we'd already done the same API split there. And so we had an API that was about 80% the same for the mobile applications. And so we took exactly the same approach again. Like we had the routing layer for the web, we created a routing layer for the API backend. And you take a single endpoint, so you basically have a software load balancer that routes to a web page. It calls into a set of services on the back end where, for historic reasons, it's a single flat namespace on a single, base URL. But on the back end, that can split out to different things, or it can go into, a monolith or not. And you put the routing layer and you say, hey, as we spin up services that can work for the back end, for the front end, you just start routing traffic the same way using the same experimentation methodology. And you just gradually shift them over. And this turns out to be super, super useful when you do business in 43 different countries, because some countries just work differently. For some reason, for us, France is very different. I don't understand why, but France is very different for us. And so if France has a particular page, it's really important in our market that, this just work differently. If you can basically do all of your routing as an experiment, if a single page is its own application, you just stand up a different application for France, for that page that matters. Now, you don't want to do this because that's another application to maintain, but you can. And so for France, it might matter. If you go somewhere like Japan, it matters. And we actually haven't stood this up in Japan yet, but we will. Because there, you genuinely have a totally different consumer behavior and expectation of interacting with the web. And so moving to this enabled all of that in a way that just wasn't there in the monolithic application. You stand up what you need, you route via experimentation to the proxy layer, and it worked beautifully. Okay, skip. Let's jump to this part because I only have limited time. So when we started all of this out, I'm not going to shift from looking at sort of the product aspect of microservice type or micro web application, single page stuff. I don't have a good name for these. Microservice, if you can render HTML, we can call it that. We started the same way, where we say we have an application, we have servers, but our servers were optimized for running this gargantuan Rails application. So like 24 cores, 96 gigs, pretty beefy servers, which we deployed everything exactly the same way when we went to Node. It's like, sure, we'll use more virtual machines, but still basically you have a dedicated server per. And as, who was it? Was it Fred who was saying? No, it wasn't Fred. It was Dan who was saying, ops hates this. Why do you need all of these servers? This is ridiculous. It is true. It is ridiculous to need all those servers. And so you switch to, hypervisor-based virtualization. You still have a lot of the overhead. And one of the big things we're trying to switch right now is the way that we think about deploying these, because there's a better model. And people have talked about that a little bit, but our deployment tools basically thought of the repo and a particular hash as what is being deployed. And it would check out the repo, check out the right hash, run a build, start the server, go. And an important change is to say, stop checking out the repo and doing a build. Your application is a bundle of stuff that is compiled. We're back to, where I started in my programming career at C++, where, you have a binary. Except in Node, you're not going to have a single binary. But you can get there. You can use a tarball. You can use Docker. You can have, there's a bunch of ways to say, I have a bundle of stuff that is versioned and immutable, and it's sitting in a repo. And I can pull that down. And then, you take one more step, and you say, we're going to run that in, we're going to pull that bundle down all together, self-contained. We'll have a standard way of starting it, and we can run it in a container. Containers are all the rage now. Thank you, Docker, for popularizing the idea. But a container, okay, actually, hold on a second. When I say a container, raise your hand if you don't inherently know what I mean. It's okay to admit ignorance. I love Node. People know things. Okay, this is awesome. I've given talks like this before, and usually like half the people are like, a container, you mean like Tomcat? And well, think about it. That's what they call it. It's a web container. So, okay, so a container, everyone here knows. I don't need to explain it. Good. And so you run a whole bunch of containers, and the overhead is not much more than a single process. And so today, we run everything on a server. What we're switching to is package things up into Docker because it's a reasonable way to package things. Although Docker may switch back to tarball for maturity reasons, but we'll see. It doesn't really matter for the node stuff. It matters more for other things like MySQL, or Apache actually embeds paths when you build it. You run it in a container, so it thinks it has a server to itself. You run however many containers you like on the server, and life is good, except we have, what, 30 some odd applications. We have, I'm trying to think, do we talk about servers? I don't know. However many hundreds of servers we have dedicated to this. And it turns out that deciding where to put these things is an interesting problem. And you're like, oh, okay, well, put these on different racks. Let me manually do that, go through and do that. And it turns out this, too, is a solved problem by a lot of people. And most of the solutions that are open source or readily available suck horribly. But in the last few years, a project out of Berkeley's AMP Lab and sort of made into real production worthiness at Twitter is Mesos. And Mesos is a cluster scheduler that you basically give it a pool of servers. They have a bunch of resources, and you say, please start up 7 of these for me. And it does. It's like, okay, here's 7 of them. Here's the constraints. Here's where they should run. This requires this many cores, this much memory. And it does all the fiddling to figure out where it goes. And it turns out all that fiddling to figure out where it goes is actually NP complete. It's the definition of modern cryptography. It's the knapsack problem. So I've implemented 3 of these. They are all horrible. So I'm glad that a bunch of smart people made one and didn't commercialize it, but productized it that I don't have to use. And I want to talk about this for a moment because there's a very important difference when you move to this model. Everyone is used to thinking about things in terms of servers. I deploy this to various servers. I deploy this to various servers. And the idea here is that you just have a whole bunch of compute resources and you deploy processes. You just run a single process again. And as a matter of fact, the finer grained you can make your process, the easier it is. Because you can say, oh, we need, this particular application, the browse page, is up to, 80% utilization of everything that it has. Add 4 more, shrink it down. You can basically get the very fine-grained scaling characteristics without ordering more hardware. Because we don't run on EC2 or Heroku or anyone there. We have our own hardware in, I think, 4 different data centers now. That's a big cost that we're probably not switching. We also run in EC2, so having a model there works. And this is where Node is particularly beautiful with this model, because your single grain of deployment, like your runtime unit, is a process that is very predictable. And so, Node maps into running this. And so what we're going to is a model where, framework is a Mesos thing that basically knows how to schedule things out there. And you could have like 20 different types of frameworks. And so then we have an orchestrator that says, hey, please put this on 1, and then as it comes up, find out where it ran, put it into the service group for the load balancer, and ease its way across the deployment. Oh, oops, that was horrible, flip back. Or spin up everything, put it in a VIP, and flip over. And you basically move to a very different kind of cloud-like deployment model, which is nice. And unfortunately, I can't give you lots of production details because we only have this running in development right now. But hopefully, this time next year, we can give lots of war stories on how this works in production. I have actually a minute left. I'm really excited. So I can take 2 questions. Nobody else is taking questions. Yes, sir?
Yeah, so when it comes to like the layout rendering stuff, why, because I'm thinking about all of this, and I'm thinking what the great thing about microservices and asynchronicity and all that kind of stuff is that they could, for instance, with Fred George's example with the car offers, they could be asynchronously updating on the client using JavaScript. As more offers come in, they could kind of get updated. So that got me to thinking, like all these sort of layout solutions, why can't they be sort of created, like a layout could just be a static HTML file with dynamic JavaScript, and then for your SEO stuff or for like your maybe mobile clients and stuff, you can do pre-rendering, start it in batch, static pre-rendering, and that's your layout. That's your layout engine done. You just do it in HTML and JavaScript, pre-render it.
So so if I could repeat the question then, so that it gets recorded. For the layout stuff, it seems like it would be very easy to do client-side rendering of most of this stuff, except for your SEO information and whatnot, which could just be statically pre-rendered into a bunch of files. There's actually a number of subtle questions in there, which I'll try to get to. So yes, you absolutely can do a number of things client-side. The things that you can generally do client-side are where latency doesn't actually matter much. Because you have to get the page, then you have to round trip back, and then you have to render, which is very, on consumer internet stuff, the latency matters. There's ways to get around that. If you look at like Facebook with BigPipe, they actually do that, and they revamped a lot of stuff in order to be able to. But it has its own sets of pain, particularly where you care about things like getting indexed by Google, which we care a lot about. And then the second thing is, can you just statically pre-render all of this? And in our case, it's very difficult to statically pre-render because if we look at, let's see, where's one of the pages? This page, this is completely customized to the person viewing it. Almost everything that we do takes into account, what little we know about you, what little intent we have. It's important to show you the right thing. Someone I knew, analogized it to, if you have a stream of 2 million people running in the door of your store all the time, can you drop exactly the right thing in front of them every single time, correctly every single time, so that it's exactly what they want and they buy it and they go out the other side and don't, sit around. So that basically stops the static pre-rendering for most stuff. And so we do get, let's see, where is... So that's what I say. We get dynamic pre-rendering of a lot of stuff with the layout server, and it caches most of what it does. It does a per user cache, for each thing. So when you first come to a page, it renders the layout for you. It sticks it in cache because you're probably going to look at another page, and we get that. But for all of the actual deals, we also, where do we go? Okay, so here, a lot of these things are genuinely widgets. Like the page that's rendering this doesn't necessarily know what the content's going to be because a lot of these blocks are widgetized. Does the browse page, this doesn't actually have a lot of the widgetized stuff in it. And so you just don't necessarily know what's going to happen enough to do that. But the latency hit of going all the way back to the client and then all the way back for each thing, you create this block hasn't loaded, this block hasn't loaded. And so you want to pre-render as much of that as you can if you can do it fast enough and send it back out. And so, the layout service, Node being inherently asynchronous, it makes it pretty easy to do that way. If your content is mostly static, you could much more pre-render a lot of it. And if you're doing something where you weren't worried about things like indexing into search engines, the client-side rendering gets a lot better. Am I running out of time officially now? I'm way over. Oh, well, I went over. I'm sorry. You got the question. Thank you.